Hey everyone, welcome back to my channel. So today we'll be going through the TI Inspire CX2 CAS calculator tutorial, and then we'll be going through the topic of circular functions. So let's get started. So here we've got the passengers on a Ferris wheel access their seats from a platform of 5 meters above the ground. As each seat is filled, the Ferris wheel moves around so that the next seat can be filled. Once all seats are filled, the ride begins and lasts for 6 minutes. The height h meters of Isabel's seat above the ground t-minutes after the ride has begun is given by h equals to 15 times sine of 10t minus 45 degrees plus 16.5. So part A is to use the calculator to sketch the graph of h against t for the first 2 minutes of the ride. Okay, so let's get started. So what we want to do is we want to go to our graph here, and then we want to start typing in the equation. So in your graphics, in your calculator, make sure the it's set to degrees here. So that one, you can always move the cursor to change between radians like this, and then click again to go to degrees. So make sure it's in degrees, and then you just quickly type in the function. So it's 15 times sine. So to choose sine, you have to go to the trig here. You can see the trig. Press on that, and then you can select sine, and then you do 10 times, so instead of t, we put x, 10 times x minus 45, and then outside the bracket is 16.5. So type that in like so. And now we want to restrict our domain. So in this case, we want to only sketch the time up to the first 2 minutes, but time is measured in seconds. So 2 minutes is equivalent to 120 seconds. So what we want to do is we need to restrict the domain to that between 0 to 120 seconds. So to put a restriction on, you go to Control and then press the equal button there. So you can start, and then you can select this one here, which can then gives us the opportunity to put the domain. So the domain is between 0, and then press Control that to get the inequality signs, and we want to select less than. So we've got 0 less than x, and then less than again, and then just put 120 like this. And then just go ahead and press enter. So you should get a graph like this. Let's say you don't see a graph like that straight away. What you want to do is go to menu, go to zoom, and go to Windows settings. So menu number 4, which is Windows zoom, and go to number 1 for Windows settings. And then make sure you put a settings where the domain, you can put it as like -10, or you can put it from 0. And then the maximum, you can put it to 120 or 150, so more than the 120 to see like the complete graph, and then put the scale to auto. And then for the Y minimum, you put 0, and the Y maximum, which should be more than the amplitude, well, not the amplitude, but the maximum value. So I would put, 35, so I can also see the maximum value and beyond. So I would put something like this in. And also put the X scale and Y scale to auto, and just go ahead and press OK. Then you can get a graph like that. So that looks all good. Okay, and then you just kind of graph that on your piece of paper there. So okay, so what we'll do is we'll just quickly sketch that on our graph here. So I'll just reshare the screen here. Okay, so 1 second. Okay. All right, so for part A, what we want to do is copy from the calculator. So our y-axis is basically h measured in meters, and then our t is measured in seconds. And it's going from 0 to 120. And basically, it's just going to go like this. 1, 2, 3, and 4. And so basically, In this case, if you want to find out, what's the maximum, so it's just basically 15 plus 16.5, which is basically the 31.5. That's the maximum. And the minimum is just 1.5. So this would be 1.5. So how I got 31.5 is just basically 15 plus 16.5, which is 31.5. And then the minimum is just 16.5 minus 15, so it's 1.5. And then if you want to find what the endpoint is, you can use the calculator. And also if you want to find what the y-intersect is, you can also use the calculator. So let's pull out our calculator again. And then from our graph, what you want to do is go to menu, go to trace, and go to graph trace. So menu, trace, and graph trace, like that. Press 1, and then just press 0. So when you press 0, you can see there's an x equal to 0. And then just press enter, and that will give us the y-intercept. So it's at 5.89. So we can quickly put that in to our graph. So it's at 5.89. And then for the x equals to 120, we can type 120. So you can put 120 here, press enter. And here we can see the endpoint is at 30.99. So I can put 30, so 120 and 30.99. 120 and then 30.99. So if we jump back to our graph here, let me just quickly share this again. Okay, just quickly bring it up. Okay, so you can see there the y-intercept is at 5.89 here. And then our endpoint. So our y-intercept is here, 5.89. And then our endpoints at 120 and 30.99. So that's basically our graph there. And then for part B, how far above the ground is Isabel's seat at the commencement of the ride? So we can see from the y-intercept, it is at 5.89 meters. And then part C is how many seconds does Isabel's seat pass the access platform? So the access platform is 5 meters above the ground. So in order to do that on a calculator, we just need to create another graph where y equals to 5, and then it should cut across here a few times. So let's go ahead and do that. And what we want to do is we want to find the first intersection between these 2 points when the sinusoidal graph crosses that h equals to 5 mark, and then get basically our x coordinate to find how many seconds does Isabel's seat pass the access platform. Okay, so let's go ahead and do that on our calculator. Okay, so to do that, we go to menu, analyze graph, and intersection, like that. Just press enter. And oh, sorry. Before we do that, we need to define our second graph, which is y equals to 5. So how we do that is you double click the blank page, like anywhere that's blank. Double click that, then you have f2x that equals to 5, like this, and just press enter. And that should give us a nice straight line where y equals to 5 or h equals to 5. And then go to menu, analyze graph, and intersection. To do that, press enter. And then move your cursor to here, lower bound, click once, and then move it like slightly over, and you can see there's an intersection there. And then just press enter. And there you have it. So the first intersection points at 27.5 and 5. So the answer for that, how many seconds does it take for Isabel's seats to pass the access platform? It will be 27.5 seconds. So 27.5 seconds is the answer to that. So the next question is, how many times will her seat pass the access platform in the first 2 minutes? So in that case, because our domain is already restricted to 2 minutes, which is 120 seconds, we just need to count how many times does the straight line there, h equals to 5, crosses the or intersects with the sinusoidal graph. So we can see here it crosses it 6 times. So, the first two here, and then the next two here, and then the next two here, where my cursor is. So yeah, so that's the answer for part D there, 6 times. And then how many times will her seat pass the access platform during the entire ride? So what we want to do is you want to change the domain again. Instead of 120 seconds, for 6 minutes, it's going to be 6 times 60 is 360. So change it to 360 like this in our original graph. The domain, stretch it out to 0 to 360 and go enter. And then, so the graph is now further stretched out. So you need to go back to your zoom settings, Windows settings. And then instead of 150, you want to go more than 360. So maybe 400 like this. Keep the Y settings the same, just the X max to 400. Go ahead and press OK. And you can see there's a lot more of the sinusoidal graph being shown. And then we just need to count how many times does the two graphs kind of intersect. So we can see there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there's 20 times. So we can write 20 times for part E. Okay. And then for part F, due to a malfunction, the Ferris wheel stops abruptly in 1 minute and 40 seconds into the ride. So 1 minute and 40 seconds is equivalent to 100 seconds because 60 plus 40, so it's 100 seconds. And then how far above the ground is Isabel isolated? So if we look back here, what we want to do is we want to go to menu, trace, and graph trace. So do that, and then just put 100 here. So just type 100 and press enter. And it's shown basically, so I'll just quickly do that. So for 100, so I just go to 100. So I'll just type 100 again and press enter. And there you have it. So you can see the blue there, 100 and then 4.21. So the answer here, how far above the ground is Isabel stranded is 4.21 meters. 4.21 meters. Okay, so let's quickly I'll just reshare what I have here so far. Okay, so which is this one here. Okay, quickly reshare this. Okay, so we've got all the answers here so far. And then now part G is a bit more tricky. If Isabel's brother Hamish had a seat 1.5 meters above the ground at the commencement of the ride, how far above the ground is Hamish stranded? So in this particular case, we have a different shift along the sinusoidal graph. So we need to rewrite this as maybe we'll just call it G. G equals to 15 sine of 10t plus, we'll just call it A, and then degrees plus 16.5. And then to solve for A, basically we need to swap the coordinates of 0 and 1.5 because at the commencement of the ride, that's when t equals to 0. We have a height of 1.5 meters. So, and that's why the y coordinate is 1.5. So that means 1.5 is equals to 15 sine of 10 times 0, which is 0. So that's just basically 0. And then plus A degrees plus 16.5. So we just need to put out in our calculator to solve for this equation here. 1.5 equals is 15 sine of A, and then in degrees plus 16.5. And just make sure to put the restriction between 0 and 360. So that's the kind of the phase shift. So let's go ahead and do that in our calculator. So to jump to the calculation page, you just press this one here, so you can skip over. And then we just use the solve. So go to menu, actions, and sorry, menu, algebra, and solve. Go to this one. Press enter, and then we just go 1.5 equals to 15 times sine of A, and then plus 16.5, and then put comma A. And then put the restriction on where it is between 0, A, and 360. So type that into your calculator here. So solve 1.5 equals to 15 times sine A plus 16.5 comma A. And then the restriction is 0 to A to 360. Make sure it's in degrees form. And then press enter, you get A is equal to 270. So that means the shift is plus 270 degrees. So then we go back to our graph here. But before that, I'll just quickly show you what this looks like in the new equation for Hamish. So let's see here. So I quickly reshare my screen here. Okay, so basically, uh, so then in this case, for G is whoops. So for G, let me just quickly share this one here. Okay. So yeah, so basically G is equals to 15 sine of 10t plus 270 degrees plus 16.5 is the function we need to type in the calculator, and then solve for when t is equals to 100 seconds. So let's go ahead and do that. So let's go back to this page here. And then we just double click on a blank page so we can type in our third function. And then in this case, it will be 15 times sine, and then this would be 10 times x. So 10 times x plus 270, and then plus 16.5. And then don't forget to put the restriction on where x is between 0 to, let's see, so 0 to, we can put it as 360. So I can type that in. Technically, yeah, you don't need to put the restriction in because we just need to solve for the the y coordinate, but we just put it in anyway. So 0 to 360, and then graph. So we can see a new graph. That's on the black sinusoidal graph. And then go to menu, trace, graph trace. Get this one here. And then so you want to kind of, so you can see this the bottom one, bottom right there. So it's currently going for function 2. We don't want that. We want to press up to function 3. You can see there, it jumps to function 3. And then just type, you don't need to type 100, or if it's not up to 100 right now, you just type 100 so that your trace for x equals to 100, and then y is equals to 13.89. So that's the answer for the very last question there. So let's quickly go there. And I'll just share my screen again. Okay. Yeah, so in this case, the for part G, oops, let's see. Okay, so for part G here, no, it's not showing there. Okay. Oh, yeah. So basically, the answer for part G is H at 100. Oh, sorry, G for 100. So because we call it a G function, so let's cross this out and this one. Okay, so G of 100 is equals to 13.89 meters. So basically, it's 13.89 meters is Hamish is being stranded above the ground. So yeah, that's it for this tutorial. If you got any questions, feel free to comment down below. Otherwise, I'll see you in the next lesson. Okay, see you later.